So we will start with the demo session. Okay. So this is the physics demo class, right? So one of the topic which is there in the syllabus is called as the lasers. Okay, no problem. Anyway, it doesn't matter which topic because just 10 minutes, right? Hmm. All right. Okay. Ah, that's fine. Right. So we'll look at what is called as the elasticity. Okay, so let's try to define the properties of materials, right? So there are fundamentally two types of materials that exist, right? The first one is the first category is called as the rigid, okay, rigid object. So what do you mean by a rigid object? Whenever you try to apply the force, right, on an object, right, it tries to withhold the force for some it has a capacity to withhold the external force for some extent, okay, but right, once it crosses the limit, right, the object breaks, right, there is, right, it cannot there is no question of what is called as a deformation, right? So that's no, there is no deformation, right? Deformation, you don't see the object changing their shape when you apply external force above some threshold. Okay, right? So that should be clear. That's the first object, which is called as a one type of object, depending upon the elastic property of materials. Anyway, we know that we can categorize the materials based on several things, such as conductivity. Yes, you can say conductor, non-conductor, semiconductor, etc. Now we are not classifying in that way. Now we are trying to classify the objects, right, or the materials based on the elastic property. Elastic property in the sense, what happens when I apply force, right? In that, the first case is called as a rigid object. Object is said to be rigid whenever you apply external force and you see no deformation. The object's shape will remain same, but it has a threshold value. Like up to certain force, it will hold that. After that, it will break. Right? No deformation. And I'll write and the object. Okay, I'll use a proper word. It's not just object; it's a material. Okay, and the material, right, breaks upon the external force, right? Again, there is a threshold. Above the threshold, it will break. Up to that, it will hold something, right? So, any can you try to give me example of such material, right? I'm looking for examples of rigid materials, right? Just okay. Let me take metal, right? Anything other than normally, if you see metal, yeah, some of the metals. Okay, let's take this as of when we continue with the subject, I'll we'll discuss as the specific concepts related to metal. Okay, fine. Okay, as of now, let's take this. Metal is right. Okay, then anything. Okay, so carbon fibers. Let's accept that. Okay, so you know that, right? So since what is rigid, we define. You are able to understand that. Okay, these are the materials, right? It will directly break. There is no concept of the object changing the shape because of the external force, right? It will directly break. That's all, right? So actually, when we go in depth about this particular subject, we will see that we'll bring the equations and we'll study further. Okay, as of now, since it's a demo session, I don't want to go to the equation related concepts. Okay, I don't want to bring the equations here. Let me try to keep it as simple as possible. Just to make you to know about my flow. How do I teach? What is the speed, etc. Right? You can judge based on that. Okay, so that's why I don't want to bring the equations over. Okay, so first thing is rigid objects. So we understood, right? Just the definition and an example. And the second set of the materials, right, we'll call them as elastic material, right? The fundamental idea behind introducing this chapter in engineering physics is that, so we want to study, right, about the elastic properties of materials. The elastic properties, first let's try to define the elastic materials. So when you apply certain amount of force, right, it tries to it tries to, initially it will not change. Okay, initially it has the properties very similar to rigid objects. It will try to withhold that force for some extent, but that is not for a larger extent like rigid objects. For very small, right, extent, it will try to withhold that, right? Once it crosses that small amount of threshold what we have, right, it deforms. In the sense, if you are applying the force, if you are pulling the object from both sides, right, let me say that, for example, directly go to the example like a rubber sheet, right? I have a sheet, right? You apply forces in both the directions, right? Initially you may not change, you may not see the change, but as soon as this happens, there is what is called as the change in the length, delta L, right? It changes. Initially you had a length, say L, now it changes by, say, delta. All right, so that's what is going to happen when you apply the force, right? So again you have certain limit, right? How much force I can apply after this deformation begins, right? So again, we have some equations coming up, right? We will decide some of the properties of the materials using which you can decide that, okay, this is the maximum amount of force I can apply on this object where it deforms. Okay, first thing is to study is a deformation. How the deformation happens and how much deformation happens, that's what we are going to study initially. Okay, so we have some laws such as Hooke's law, right? We have a stress strain concepts coming up. All right, okay, so you see that, right, it elongates. As of now, in what we have discussed so far, we understand that, okay, there is a increase in the length of the object for the time, length of this material. Again, after certain say, again there is a threshold for this, for elongation. After that threshold, the object breaks once again. Okay, there is no, it's not going to be the deformation after that, it simply breaks. But there is a special feature about the elastic material. Whenever you see the elongation is happening, in the sense the deformation, I'll call this as the deformation. Whenever the deformation happens, if you release the force, right, I live, I make the force equal to zero, right? What happens? The object regains its original value, original whatever shape it is. That's the, in this case, it is L. So the delta L gets cancelled and you get your length back. Original shape of the material can be obtained in case of elastic material under some conditions. Not always, right? If you apply a huge force, it will break. After that, no, you cannot. But within the limits, if you apply the force, you can see that yes, object changes its right shape, right? But within that limit, if you leave, right, if you leave the, if you make the force equal to zero, whichever deforming force you have applied, if you try to make that zero, it will come back. So the very important feature is that, right, okay, let me write in this way. During deformation, during the deformation, if the deforming force is removed, all right, if I try to remove that, right, the object or the material, the elastic material, regains its original shape. That's very important. So why do we need to study about this elastic material? What's the specialty? This is one very important engineering application, right? So everywhere, most of the mechanical, right, fields, we see that, right, the elastic materials are being used, right? So to just to sustain with a certain amount of the force, most of the time external force. It may be in vehicles, right? Maybe in the various applications. We can think of a lot of applications where the elastic materials are being used. Okay, so in this whole process, right, I'll try to brief out what are the various topics that we are going to study, right? Anyway, so this actually begins with the definition of elasticity. We bring the concepts of stress and the strain, right? Two types of uh, concepts we'll study. Then we have actually the Hooke's law, right? Maybe slight variation in your syllabus, right? But I'm talking in general about whenever we discuss about the elastic properties, we discuss these concepts. Okay, so there is elasticity. Parallel to that, we have what is called as a plasticity, right? You may have the concept of the breaking of the elastic material. It's called as a the fracture of the material, right? So that's a technical term. Then we have how much an object can sustain, right? It's defined by what is called as a Poisson's ratio. Then, right, and then you also have a concept called as see, elasticity is even in when it comes to the metal. So when you told rigid object example as metal, I told there is some concepts related to that, right? All the metals may not be belonging to that category. So that's why, right, I told I didn't discuss about that metal concept in detail, because inside the elastic material we have the metals coming into picture. It is called as a bending of the yes, okay, beams you have, right? Inside the beam you have the metals only. Okay, so that's why I never considered metal in detail when you told that okay, metal is an example. Okay, so there is a beam. When you apply the force at the end of the beam will bend. But you remove the force, the beam will come back to the original position, right? So again, that's not. It's actually a linear concept. You can even have a circular concept for that, right? You can apply a circular bending, right? And even the same similar things will happen with the cylinders. We call it as a torsion, etc. Right? So many concepts are there related to the this particular concept, right? This the basic concept is elasticity. First we study simple concepts, right? Then we'll apply them to the engineering concepts, and we'll derive something. We'll try to solve the problems, etc. Okay, so that's what is the overall idea about the particular topic called elasticity when it comes to the physics.